Hi my dear students, welcome to my lecture. This is Probability and Statistics, and in this Probability and Statistics we are going to discuss the distributions. As you know, there are two types of distributions. One is discrete frequency distribution, another one is continuous frequency distribution. So in this lecture we are going to discuss a special type of discrete frequency distribution. What is that special type? That type is the binomial distribution. And after that, we are going to discuss a problem, followed by another distribution, Poisson distribution, and a problem. That's it, the task completed. Okay, let's come back to the binomial. See the name itself, binomial distribution. What is meant by bi? Bi means two. The next, nomial. Nomial means two. So what is the name explains? Two-term distribution. So what is the natural question rises in our mind? What are those two terms? What are those two terms? It should be number one, n. What is the dn? The number of trials. The next one is second one, p. What is p? What is the subject we are studying? Probability, okay? So the probability of success. The probability of success. If there is a probability of success, there should be a probability of failure. So there should be a probability of failure, and that is denoted by Q. What is the relationship between P and Q? P and Q are the probabilities, and the total probability of success plus probability of failure is equal to 1. Understand, both the probability of success and failure are the probabilities, hence this should lies between 0 and 1. So what is the speciality for the binomial distribution? So for the binomial distribution, there is a probability mass function. The probability mass function can be notated by PMF, and it is P of x is equal to NCX multiply with the P power x multiply with the Q power n minus x, comma, the x varies from 0, 1, 2, etc. till the number of trials, n. Till the number of trials. Now, what is C? Combination. The number of ways of selection. You can do simply with your calculator. Okay. In this probability and statistics, from the starting onwards, we discussed with the mean, median, mode, standard deviation, variance, everything. Here also we do have. So, the first basic one is mean, and the mean is NP. The next, it is variance. The variance is NPQ. The variance is NP and Q. Okay, let's come back to the problem, how to resolve. Okay. Consider a situation. A situation is given as a problem over here. This is the application, the direct one. A shop owns 400 laptops. Each laptop has 8% of probability of not working. So there is a shop, there are 400 laptops, and each laptop, there is a probability of not working, broken. The chance is given, 8%. If you select randomly 20 laptops, you are going to the shop, you are selecting the laptops randomly for your shop, and you are testing. So you select randomly 20 laptops, find the probability of 5 will not be working, and mean variance standard deviation. The first task, what is it? To find N and P. So what is N? N is equal to, the most important one, how many laptops you are selecting, how many trials, for what you are checking. You are selecting 20 laptops. This is what you are going to test now. So N is equal to 20. You are randomly selecting 20 laptops. What is the probability of success for every laptop? It is given the P as 8%, means 8 divided by 100. Now there is one more. What is it, one more? Q. So what is the relationship between P and Q? P plus Q is equal to 1. So Q is equal to 1 minus P. Get into that. So it is 1 minus P. 1 minus P, it is already found, 8 divided by 100. So it is 92 divided by 100. So the first task has been completed. The next, the probability mass function. Write the rule. What is that rule? P of x is equal to the rule, probability mass function, NCX, P power x, Q power n minus x is equal to 0, 1, 2, 3, etc. till n. Apply the values whatever you found first. So your PMF now is P of x is equal to, it is 20Cx, we don't know our x, keep your x as it is as of now. P, it is 8 divided by 100 power x, and Q found, it is 92 divided by 100 power n. N is 20. 20 minus x. And x is equal to, as usual, 0, 1, 2, etc. till n. This is the probability mass function. From here we are going to calculate. What we are going to calculate? 5 will not be working. What that 5? Probability of. So it is x is equal to 5. Probability of 5 will not be working. So it is x is equal to 5. Apply x is equal to 5. So it is P of x is equal to 5 is equal to 20C5. 8 divided by 100 power 5, 92 divided by 100 power 20 minus 5 is equal to your answer. You have your wonderful calculator. You can do your solution. Now, the next, mean. What is the mean of the binomial distribution? It's given, NP. So it is n into p. The number of items n is 20, and probability of success. The probability of success is 8 divided by 100. The 8 divided by 100 is equal to the solution. The next, the variance. The variance is given as n into p into q, so it is 20 into 8 divided by 100 into q is only given. The value of q is 92 divided by 100 is equal to the solution. That's it, a simple task we do have. There are similar problems even you yourself can create. Okay. Let us come back to the next, the Poisson distribution. The Poisson distribution has a probability mass function PMF. The PMF is given as P of x is equal to a power minus lambda, lambda power x by x factorial, comma 0, 1, 2, 3, etc. Okay. And as usual, the mean and variance is given. The mean and variance is equal for a Poisson distribution and it is given as NP, it is notated by the letter lambda. The letter lambda. Okay. What is lambda? The parameter. What is the rule? N into P. What is N? The number of trials. What is P? The probability of success. We are not going to discuss the probability of failure here in the Poisson distribution. Okay. Come back to the problem. If 2% of the components produced by a machine are defective, in a box of 200 components produced by this machine, find the probability mass function, mean and standard deviation. The mean and standard deviation. Okay. So what it is given in the question? There is a box. In that box, 200 components are there. It has been already known that 2% of the components produced by a particular machine is defective. What the boxes contain? That contains the same components. Now we have to find this following. So what is our N? N is equal to the box of 200 components, the number of items. It is 200. What is P? The P is given as the probability of success, 2% of the components produced by this machine. So P is 2%. That is 2 divided by 100. Immediately go for the mean and standard deviation. The mean and variance. The mean is equal to variance is equal to lambda is equal to NP. N is equal to 200 and P is equal to 2 divided by 100 and cancel it, it is 4. So lambda is equal to 4. Lambda is equal to 4. So what is standard deviation? Standard deviation is the square root of variance is equal to square root of 4. Take the positive square root and it is 2 as it is a deviation. The next one, it is the probability mass function. Write the rule. P of x is equal to x is equal to a power minus lambda, lambda power x by x factorial, x is equal to 0, 1, 2, 3, etc. Apply the values whatever you found, and this is e to the power minus lambda. The value of lambda is 4. Multiply with the 4 power x by x factorial, x is equal to 0, 1, 2, 3, etc. As of now, the task is over. For this problem, the task is over. If at all they ask you find the exactly 3 defectives, then what you can do? You can directly put x is equal to 3. So it is e power minus 4, 4 power 3 divided by 3 factorial, and you can get your answer. You can write it over here. Is it fine? Can you understand? Okay. Do you have any questions? Absolutely, you should have one. We discussed the 2 things. Number 1, binomial. Number 2, it is Poisson. A question is given. A situation, application is given. How to identify whether it is binomial or Poisson? Through what we can solve? The answer is quite simple. Check the number of items. It's 20 and it's 200. If the sample is a small sample, utilize your binomial distribution, and if it is a large sample, use your Poisson distribution. So on what criteria we are deciding whether it is small sample or large sample? The universal one, just for the sake of convenience. If the number of items is less than 30, we consider this as small sample, and we can use this part. What is that part? Binomial. If the number of items is greater than or equal to 30, this can be considered as the large sample, and you can use the method of Poisson. Hope you understand. The questions might be posted to you, and you can explore yourself for the rest of the different applications and the different problems. See you on another video. Bye bye.